Good morning everybody. Today we're finishing off the chapter on volume and surface area, and so what we'd like to do today is just have a quick review of all the formulas, and then we're going to have a look at some questions. I'm going to have a go at some. You guys can do one which is quite similar, and then I'll set you some exercises to finish off. So first things first, just a recap of the formulas. The formulas are in front of you: volume of prism, pyramid, sphere, cylinder, cone, and the surface area of a sphere as well. If you haven't seen these, can you have a quick look back in the chapter, because you've possibly missed a little bit of work. If, for instance, you don't understand what the L is here, for instance, then have a quick look back in the chapter and you'll find where you first came across it, and it will give you a picture of what the L means in that particular case. Okay, so let's have a look at how we're going to go about things today. So you'll be given a series of questions, and it will be compound shapes, 3D shapes that is, and you might be asked about the surface area or you might be asked about the volume. If you're asked about the surface area, you need to identify all the two-dimensional shapes you can see, and if you're trying to work out a volume question and it's a compound shape, so it might be a cylinder with a cone stuck on top like a rocket, similar to the SpaceX one yesterday maybe, then you need to identify what shapes they are, and once you've identified all the shapes that you can see, you then need to recall the formulae for those shapes and write them down somewhere. Write them down in your working. So you're telling the examiner, I've identified this shape and I've written the formulae down. And then you must show all your working, and don't forget your units at the end. Show all your working because you want to write the formulae down, you want to show the examiner you can substitute into a formulae, you want to show the examiner that you can simplify your working, and also you also want to show your units at the end, and you understand the fact that there's different units for different sorts of working out. Okay, so let's have a look at a couple of questions. So here's our first example. It says calculate the surface area of these shapes. There's only one here. You're going to try this one in a sec for me. So let's have a look at what we've got. Stage 1 was identify all the shapes that we can see. So here I can definitely see a square and I can see triangles as well. So what I'm going to do is I'm just going to write square down, and because I'm trying to work out the surface area, I want to work out what the area of the square is. Okay, so area of a square, well, area of square is just the two, well, let's put I don't think we've ever had a formula for square, have we? Because it's so easy to do. So if we thought about it from a rectangle point of view, we'll put length times width. In this case, I'm just going to put 7 times 7 because that's what the area is. It's just the two sides times together. 7 times 7 is going to be 49, and you'll notice that all the measurements here are in centimetres, so it's going to be 49 centimetres squared. If I've never taught you before, you might now be thinking, God, he does his nines weird. Yes, I do. I'm sorry about that. Okay, so that's what the area of the square is. The other shapes I can see are triangles. And you might be saying to yourself, okay, would I write my working out like this in the exam? Would I write square? Would I write triangle? Yeah, please do. It's really useful as a marker to see what you've been doing, why you're doing it, and if you try and make your work go down the page, or it's organised in such a way that it's really clear what you've done where, it's a lot easier to give you marks for things. So for the triangle, the area of a triangle is half. Let me just check how it's written down at the start here. It's not written down there. Okay, so the area of the triangle is half base times height. If you don't remember some of these formulas, have a look back in your book. I can't remember what chapter it is exactly, but look for area of 2D shapes or something like that in the index. So half times base times height. So for the triangle, we can see that the height of a triangle is going to be 10 centimetres, and that's the perpendicular height, the height from the bottom to the top of the triangle. It's not the slant height. This is the slant height here. We want this height, the perpendicular height. And we also can see that the base is 7. So the area of the triangle is going to be half times the base, which is 7, times the height is 10. Half times 10 is 5, 5 times 7 is 35. So the area of a triangle is going to be 35 centimetres squared. And then a common misconception to do now is for people just to add those two together and say that they're done. However, you also need to remember how many triangles you've got and how many squares you've got. You've done some working, and now you need to give the answer. So it's useful to use a connector such as therefore, and then say therefore total area, because one of the marks in the mark scheme will be saying using their previous working calculates a final answer or something like that. It will be basically looking for a process of you adding some stuff together that you've already done. So total area is going to be, well, it's going to be the square, which is 49, plus the triangles. There's 4 of the triangles, so it's 4 times 35. And if I add all those together, I'm going to get 49. 4 times 35, 4 times 30 is 120, 4 times 5 is 20, that's 140. So the total surface area for this one should be 189 centimetres squared. I generally double underline my final answer because it draws the marker's attention to it, and if it's right they may just give you the rest of the marks anyway. If not, it's really clear that I've done something here, something here. I've then said I'm adding them together. It's really clear where all the marks should be given. Okay, what I'd like you guys to do now is do a very similar question. This one. Can you have a go at this one please for me? Can you just also pause the video now while you do it? When you think you've done it, unpause the video, and I would have written some working down. Okay, pause the video now please. Okay, so the first bit would be to work out the rectangular base. The rectangular base, well, area equals length times width. I've written down my formula to say that I know it. The length and width are 10 and 18. Times them together, I get 180 centimetres squared. So just check you've got that bit first. The next bit, trying to work out the area of the triangle. So for the first triangle, let's call that this side. You've got half times base times height, which is half times 18 times 15, which is 105 centimetres squared. If you use just this triangle 4 times, can you now have a quick look back and see the fact that you should have used this one only twice, and see if you can work out what the second one is? Just pause the video and have a look at that. So the area of the second triangle is 65 centimetres squared, half times base times height. The base is 10, the height is 13, half of 10 is 5, 5 times 13 is 65. So for the total area, you need to add them together. You need to add the rectangle to 2 of triangle 1 to 2 of triangle 2. So that's what I've written down here, 180 plus 2 times 65 plus 2 times 135. So it gives me 180 plus 130 plus 270. Let's try that again. And if you add all those together, you're going to get 400 from these second 2 bits, so it's going to be 580 altogether. 580 centimetres squared. Okay, so if you've made any mistakes on that one, just write some little notes to you against your work, and just anything that you might need to remember for future. Let's have a look at another question. So here's another question here. We're going to do this in part together. James is going to fill a paper cone with sweets. Lucky James. He can choose between cone X and cone Y. Cone X has got a radius of 4 centimetres and height of 8. Cone Y has got a radius of 8 and height 4. So let's swap the measurements around here. Which cone has the greater volume? So we're just going to do that first bit together, and I'm going to have a look at doing cone X. And so let's just think about what I need to do first. So the question says that it's a cone. Remember, we need to identify the shapes first. It's a cone, the question tells us. Recall the formulae for the shape. So I need to look at my formulae. So the formulae for this, I want to do the volume of the cone. The volume of the cone isn't here, that's a bit annoying. However, the volume of the cone is the same as the volume of a pyramid. Third of the base area times vertical height. So a third of base area times vertical height is the volume of a cone and pyramid. So let's have a go at that. So the area, so let's do cone x. And because I need to work out two volumes, I'm going to do cone x, work out the volume, cone y, work out the volume. And I'm going to make sure that I label the fact that I'm doing cone x first. So it's a third. The base of a cone is a circle, so the base area is pi r squared. So a third times pi r squared times the height h. So we've got a third times pi times, oops a daisy, let's just get rid of that. The radius is 4, so that's going to be times 4 squared, times the height's going to be 8. Okay, so I need to bang that one into my calculator. When I stick that in my calculator, all together I get 134.04 centimetres cubed. Centimetres cubed because it's a volume. Okay, with this sort of question, it's not obvious how many decimal places you should do. I generally do just a few decimal places, maybe write about 5 digits down for my calculator. And that should be sufficient. You should give your final answer to 3 significant figures if it says what's the volume. If you're going to work with, so it says here which cone has a greater volume, that's not an issue. It says what's the difference in volume between cone x and, oops daisy, let's just get rid of that, cone x and cone y. Because it's asking for the difference, what you really need to do is have more than 3 significant figures for this bit and more than 3 significant figures for cone y. So then when you give your answer to this question, you can just give it to 3 significant figures and you'll know that it's actually accurate. So I've just done cone x. What I'd like you guys to do is, can you do cone y please? And once you've done cone y, that's not how you spell cone, can you come back to the video please? Just pause it now. Okay, so hopefully you found out that the area of the volume of cone y is 268.08 centimetres cubed. Using this work in here, the radius is now 8 and the height is now 4. Okay, so just before we have a go at part B, you may have been surprised about the difference in the volumes, considering that all we've done is swap the heights and the radiuses around. And the reason why it's so different is because of this bit here. It's because we're squaring the radius. And so a big change in the radius makes a big change in the final volume. Whereas for the height has not been squared or anything particularly big been done to it. So if you make a big change in the height, it doesn't necessarily make a huge change in the volume. Okay, so let's just have a quick look at part B before we finish. What's the difference? Well, the difference would be one take away the other. So what you might do in this situation is you may end up doing this 134, take away this one and get a negative number. Obviously we're not interested in negatives here, so make sure you use the biggest number first and take away the smallest number. So the difference is going to be 268.08, take away 134.04. 134.04. Make sure you write that line of working down, because if you don't write that line of working down, then the examiner won't necessarily know what you've done. Okay, if you got this last bit wrong. Okay, so the final answer for this is going to be 134 centimetres cubed. I've taken cone y's volume and taken away cone x's volume. You'll notice I get 134, and that's to do with the fact that you get an extra 2 in here because of the squaring. Okay, so that's those two questions I had a look at. There's question 7 to do, slide 7 to look at quickly, which is the exercises for today. So your exercises for today, can you do page 327, question 3, 5, 6, 7, 8? I haven't put 1 and 2 down because we've just done those together. And if you want a challenge, can you read example 2 on page 326? It's the one that involves Pythagoras' theorem. And then try question 4 on page 327. Have a lovely day, and I hope I get to see some of you soon. Bye-bye.